Okay, if you have windows still open from the previous tutorial and such, you could just close all those, and we'll just kind of do it all again as a memory refresher. How's that sound? So the next exercise here, we played around with a lot of ones and zeros and tweaked them and then talked about it for a half hour, what a good that is. Why don't we actually make a program that does something? I've opened gedit here, and of course a keyboard is always useful for these exercises, and so we're going to send a command to the processor. Remember, this is written in assembly, of course, and this command will just ultimately turn it into a number. AX 0 E 31H. That's pretty good to go. And then I'm going to say int, and this is not integer, by the way. This is an interrupt signal to the processor to do something, and we're going to send it a value which is 10H. That's 10 in hexadecimal. The H signifies that this value is a hex value. Okay, so there we go. I'm just going to save this out real quick. And once in my assembly Lexar, there, that's my removable media, whatever. Yours will probably be something else. Assembly files, they're O2. Here we go, O2.asm. I'm getting real creative with the titles here, and there we go. In there we are saved. We've made some working code here, but this program in itself will not run, which we'll demonstrate shortly here. But I'm going to go ahead and compile it from the terminal here. Yeah. Okay, so I'm not in that folder, so you know the drill. We're going to go to the file itself. Whoops, I grabbed the other thing. I'm going to put that over there a little bit and move that over there a little bit. That's probably a fast way to do all this. And find the file in the assembly folder and just right click on it to get the properties. And when I right click there, select all, right click again, copy that, and I have the path, so I can just go over here and, whoops, don't paste yet. I need to change directories and then right click, paste to that folder. Okay, ready to go. Let's compile it. NASM, right? And this will be O2 tab. It finishes it out. Let me say -F type of file is a binary file. The output is going to be o2.bin and enter, and there we have, whoops, what I wrote 2.0. Okay, I accidentally typed 2.0 instead of O2. I'll just rename from here, just keep it simple. There. Right click to rename. Okay, great, good to go. So there's our binary file. Okay, and we can just go ahead and look at it real quick. In ghex o2.bin, right, and there I made some commands in some cryptic language called assembly, and once again it turns it all into a bunch of ones and zeros, which we see here represented in hexadecimal. Now, okay, great. Here's another interesting thing. Here we wrote OE 31, and what we get back is 31 OE. Okay, so this is your little Endian system here. Okay, so yet another of the quirks of programming in your particular processor, and that when you send it a 2 bytes, 1 byte, I'm sorry, 2 nibbles hexadecimal value, it gets reversed. It takes and why is this? Well, you can look all over the internet, you know, and try and find some answers on that. And I have never found one. And I can find a lot of speculation. You know, people like, well, I would guess that they did it for this reason, or well, I think that they did it because now it makes it easier for you to put certain values first, and nothing definitive. You never see like somebody, oh well, I worked at Intel and we did it for this reason and that reason or whatever. No, it's like so while the entire computing world is taking pot shots at it, why don't I take a wild guess why they did it too? Why did they make this backwards like this? Marketing. Because they wanted to release a new processor that was, you know, slightly faster than last year's processor, no huge deal, you know, and try and sell it to the world who had complained about the fact that, hey, what is all this stuff using bits, moving bits all the time? I can't handle all these bits, you know, and like, you know, so like, okay, they could go, well, our new one works in bytes, you know, 8 bits. You know, right? Oh, we got our 8-bit now. You know, this one works in bytes. You know, and which of course anybody that had been programming for a bit would go, well, so did your previous one. All I had to do was declare 8 bits, and I have a byte. You know, big whoop. You know, and to which they responded, yeah, but this one's backwards. Okay, so that's what makes this processor different from the previous generations of processors, and we are stuck with the legacy of it. You know, great. Just another crazy workaround of many, you know, from the common sense of lower level programming. Okay, there. So we've compiled our a program, okay, and next we're going to try and actually run it. I can tell you we're going to get a little error. There's a minor thing that I'm going to talk about next, but we're going to run our program in the next video.